So where I think morning Sridhar will explain about how we can do for the hydrologic modeling and how we can convert the rainfall into runoff. We can discuss like a, so when you are modeling, sometimes we are more interested or we need to go for something called forecast. That's like, that is more important for us to do like to take some measurements for the, you can say, readiness or risk management to reduce the impact. So for all the things we require a forecast, and so we are basically in this thing, we are basically dealing with the like a event based runoff. Means like for example, when event is there, especially the any hydrologic event where the rainfall occurs, like a thunderstorms. Okay, so suddenly a heavy rainfall, like in the cyclonic storm, heavy rainfall occurred at one particular region, and it is like a span for few hours, or at least only for 1 or 2 days maximum, or few hours. That too like a very means high thunderstorms like only for span for only 1 or 2 hours. So in all those cases, how that can be forecasted early, so that that can be known like how much is going to run up at a particular point. So how that can be done and what type of concepts are available right now, what is the modeling concepts available. So how we can really achieve that lead time. So those things one by one we will see. Problem laptop issue. We see some case like I said, like we are means we are doing the research in this type of things, like how to develop the forecast models. We will show some of those things for you. So here what is the, you can say the main you can say the modeling methods for this event based forecast is there. So you can see the, we will basically see for the what type of hydrological process we may consider for this forecast. That is a physically based model or it is a lumped model. So normally any of the, you can say the concept we are using either physical based or lumped based model. So any of you know that the difference between these two, physical based model? So I think some of you are working in the hydrology previous discussions. Physically based model means you are using some equations. So fundamental equations, like for example flow is there, so we will use అంటే విజిబిలిటీ ఉందండి, లేదా కంటిన్యూ చేద్దామంటే చేద్దాము అక్కడ. సో ఫిజిక్స్ బేస్డ్ మోడల్ మీన్స్ we are using the fundamental base equations, maybe especially this type of event based runoff. You will use something like, if you see the literature, those things you will get, that is called actually it's like a complete flow equations. They are called actually Saint Venant equations. So it is like all like some of you see in the fluid mechanics, like equations will be there, like energy and then continuity, two equations will be there, right? Similar type of equations they are called actually, that they are called Saint Venant equations. So those equations are used, and you will develop for entire system, entire basin. You divide that into the, you can say, grids, and then you develop that model. Those things are called physics based model. So lumped model means it is a simple you can make some like a regression equation, or you will use something like a equation is there, like for example there is a formula in the, you can say, calculating the runoff, Q is equal to CIA, that formula is there, right? So that type of things are the, you can say, simple, you can say they are, those things are called as the lumped models, or SCS curve number technique. Some of you are maybe using in the, you can say, simulations. That is a runoff, that is like a lumped model. Means so many like a parameters we are not taking the entire system of the basin into consideration, taking an average equation for entire basin, or simple equation, empirical equation you will use and you will take and you will work. So those things are called as the lumped models. So normally now the machine learning algorithms, right? It's like a training model. So we will give the input data and you will train with some black box model and you will get the runoff. So those things also will come under some category of this lumped model. But sometimes the forecasting with those things may not be reliable. We need to see case by case. We will show some of those things here. And for the, especially for forecast, this is also very important, whether you are using a hydrologic model and hydraulic model. Normally for a forecast, so especially for the thunderstorms where the flash floods are there, so where we need to know the, you can say, the flash floods, right? At the any point we need to know how much peak will come. That is important, right? So where we need to it is like hydrologic model will not work. Hydrologic means simple continuity equation will be there. There the time component will be there, right? So time and then what velocity those things will come, that will not be taken care. So the velocity of the flow is not taken care in the hydrologic model. That will not work much in the forecast, especially for the flash floods. So in that case we need to go for the hydraulic model. Means what is the forecast you are doing? You are doing for a short, very short flood, having the flash floods, or doing for a long term simulation forecast for like a 1 month, 2 months. Accordingly we need to select these models. That's what is the main thing. And all these things, this model, any model, like just now the Sridhar is explaining to you, right? Watershed thing. So watershed is the basic unit for most of our models. You can't take any administrative unit. We can't do like that. So most of our models, like today, tomorrow you are working across HMS or letter across, any other things, watershed is the basic scientific unit. So you can see the steps in the any model you take, these three things will come. First we need to take the formulation of the particular process, make some calibration, then apply the model. So here is like three things. Whatever you do the forecast model or basic model, input function to input the data. So then there is the output function to see the how that data we can visualize, and transform function. This is exactly you will see in the HACRAS or HMS model tomorrow you are doing. You will see what is these three things. So input means you will prepare data set, output means you will visualize the output, and transform means you will select few functions to convert that rainfall into runoff or those things. Okay. So it is like a simple equation like means like a flow. So most of the things like anything usually this is the conversion process from the precipitation to the finally to the where it is coming to the stream. From there we will try to simulate the you can say the flow. Okay. So here most of this you can say forecast things. So these are the things you will try to use these forecast models. These are all like you are going to try. So next 2 days you will work on these two things. So this is like they are all similar models, and then at this for this particular thing we will not go with SWAT model, but it is one of the model, especially continuous simulation. You can see it is useful actually, like a climate forecast or climate for like next 50 years what is the forecast you want to do, next 20 years climate change how it is going to impact. For those things we can use SWAT. But we tried for even for event models also we tried this SWAT model, but normally its application for very short span of events it will not work much. Some SWAT, some other models are there in SWAT only, where we can need to modify those some of those algorithms, then we can even apply for event based also. Conventional SWAT model directly you can't apply for the event based model. That's what I want to tell you here. This is like even quality also we can do that event based thing, that is like a, but most times now presently this model as a lot of things are coming in other things, we can't see much of the things in the currently this AGMPNS model, where it can do both things, quality and quantity. So WIC model, variable infiltration capacity model, and some of the groups in even like NRSC we told like they are working on this WIC model, some of their simulations especially for the forecasting the floods for basin level, basin scale. Okay. So this is already Sridhar may explain to you entire concept. We directly move to this forecast concept. This is like what we are interested thing actually. So here in a space and time wise, right, the event is occurring, that way I am explaining here, some event is occurring, rainfall event. So before the flow comes to the one gauge outlet point, before only we are going to estimate how much is going to come. That is the actually the aim in this forecast, this type of runoff event based thing. Okay. So it is like a near real time, means like at least a few hours advance, few hours only. Okay, this is near real time, that's why it is called like its event is started. So then the rainfall is occurring actually. So then in a course of time we need to get the simulation, how the runoff is going to occur, how much is going to come, like that. So it is like a nowcasting, it is like almost like a nowcasting, but it is like will be in the few hours of advance, that's what is the thing. So here this all like it is like a one way, just like a model will not take, so many other connections has to be there, nearly somebody has to implement in a scale actually. This type of things are all like required actually. So we require the data set, transmission, simulation, then once again giving to the users. So these all things has to be there. The connected things actually. So you can see like how we can conceptualize this thing actually. For example, like this is a one basin. Now casting means it's like a real time casting. Now casting means something is occurring, you can say thing. Now only we are getting, for example, event is set actually. Now rainfall is coming. So you are going to estimate what is going to be the runoff at different points and what is the amount of flood is going to occur. Event is not concluded, or it is not going to come later sometime. It is now is happening. Now only we are you can say simulating and we are presenting to the stakeholders. What is that? It is future means like a few days ahead. That is not now casting, right? Few days means now it is like event is occurring, rainfall event is occurring. Now you are simulating how much is going to flood is going to occur in a place. That is now casting means now present what is happening. Simulation means set actually means it is like a from telemetry you will get data, you will take and simulate and give the things. So forecasting means like a head means like a 1 week or few days means you will take some forecast data of rainfall also, that will give input and then you will simulate. So even rainfall event is not set also you can able to simulate. For cyclone they said like a, for example cyclone is set right now in the Bay of Bengal for example, it is a depression stage only. Now it is going to convert into like a cyclone and then right, then you are doing like that, that is become a forecasting. So it is become a is like a cyclone, rainfall is occurring, now we are predicting flood for example at one point, that become a now cast. That way is the variation actually, very small difference. So it is like a you are going to means like a, there is some forecast about these things or you are going to simulate, right? So you are able to predict or you have to get some information on a real time basis. So then this is like a asked information has to get it to the you can see the place where we are doing simulation on this particular basin. Then so it is like a simulation we are doing, right? That is the connection. Then this is what exactly the simulation will come for us actually the when the you are getting all this information priori, right? Well in advance at this point for example at this area you are going to get this one. Okay. So then so like a amount like even across or whatever the model, right? How much is becoming as a so for example this is like a outlet, right? This amount is there, how much it is spreading over the things, that's where we are interested actually. So then finally impact. Okay, it is all like a connected things, I think you are getting right. So these are the connected cycle when we want to plan for any like a event based forecast you are doing. So everything you have to take in a control means has to be there so that we can do a real time really a forecast you are doing means that's normally the like a they are planning route now in the you can see this is called actually the impact based modeling. Event is set, how much is area is going to submerge, how many things are going to damage also we can able to tell. That type of things is possible. So here so these are all things really you want to make it means you need to have a lot of frequency data sets well in advance for you so that they will help you to set the model and then do the you can say this forecast and then present. Okay. So these are the, of course dam is important and these are like a bone, these are all like a places where you will get data set actually. So these are all like a soils. So here event based means we require a something very important thing is one is observed, there we can have the so you can have this one. So dem and these are all things we require. So this all will help us to as especially to set the model, to check initial check and then make it as a forecast model. So you will see like how we are using in the one case we are presenting that we can see how those things are there. So you will see right now we will show you like how really we can apply this concept and then we try this one. We tried some cases just you can see the model actually. So this is the actually one project where we worked this type of setup we made and then we tried actually this forecasting concept actually. So here so we first of all taken some few automatic weather gauge station and then you can see the stream flow where the outlet is there and then this is like a telemetry type of thing we are using and then we are planned for a simulation of these things. So this is like a project we concept we presented and then we got and then we tried this one. Some success further work is happening on this particular domain. So we will see how I will show you here. This is the one area nearby place we took actually initially to try this model actually. So you, just you see this one. This is the different data sets on that particular model. So here this is the few places like where we install the gauge station actually, digital water level recorder and automatic weather station. So and this is like I said like this is like a distributed model. Means that is called physically based model, right? We need to have this grid. That is like the FEM grid, finite element model based grid actually. That's where we will give input and it will simulate. So here this is the setup we made actually, build all the things, and then this is the like a gauge like where we can make the flow measurement also. So that's all setup we made actually. So here that is the like this is the whole process actually. That is the we set. This is the way. First there is like one experimental model set will be there, and data you will go into get. Database all will prepare. There is like one set will be there, and then this is like a database you prepared and there at the model, right? Here that is all these things. It is ready. Set up the things. Then other one is forecast model, and then that is like a these are two types of things. For example, rainfall is we can get from rain gauge station in real time. That is one aspect. But we need to make little advance means rainfall also we can forecast. That is one concept. And then giving to you can say watershed model, it will simulate. But you are calibrating, you are not doing it. That is not our aim to just to see the model how it is working, right? We are using as a forecast model. Then what we can do, there is some error will come, right? So, and that is called actually during the course only we can correct that model. Error correction in the course of the event occurring. That is the third concept. So, these three things means combined means we can see how that is going to occur in a simulation. We can see. So, here this is the overall flow. For example, this is like a model M1. So, this is like a just like a the concept like a how the rainfall forecast will be there. This is something like a rainfall forecast how it will be there. This is called one type of, you can see the model actually. This is called gray model where few data sets we are given. For example, 3 hours of rainfall we are giving, like a point rainfall we will get right in the weather station. 3 hours rainfall we give. It can able to predict next 3 hours what. That is a gray forecast model. It's called actually. Means it has to set one. You can say the way how it is occurring. It is go on predicting the thing with some level of accuracy. So whether we can give rainfall real what is occurring or we can do this forecast. This is one concept. Okay. So then the second is this rainfall we are giving in the model, right? Then it will go to the, this is all like a model I am saying like a physics based model, hydraulic model, infiltration, overland and channel and finally predicting the discharge. Okay. This is the M2. So then it will go to M3 means we can directly see or we are forecasting, right? We want to make it some correction here. That is like a level M2. So then you can see how the M3 like it will occur actually the M3. So what is the M3 it will occur? Whatever the data you are giving M2, right? So we can give this one, we can make some inference, so you can say fuzzy inference rules will be there. So accordingly you will correct that whatever runoff you are simulating, right? You will comparing with the previously simulated data set. So we will try to like improve that particular, you can say the whatever the forecast you are doing by already happened event. For example, 10 hours of rainfall you are simulating, right? So first 3 hours already you simulated what is going to occur. Means first what you will do is what is observed you know and what is already forecasted simulation you know. So you will try to reduce the correction, means you try to reduce the error. Accordingly same correction you will apply for the next 3 hours also. So that whatever the outlet discharge also we are improving. So that's where it will occur. So you can see this how it is really happen. This is the background, you can see data sets, DEM. These are the, you can say the basin. Means like we tried, I said like one is Warangal we tried actually. Same thing like we tried, it is like a real time has to occur, right? Later some point at time what happened is some flood occurred and that systems got damaged actually whatever is installed. We thought like some events already occurred, right? Already some places already this all event based rainfall is already captured, runoff everything is there. So what we thought is like we can apply for those things also with all the data sets. That's what we tried with a backup data set. So these are the some of those things. We will show you the, these are like for a special event thing is very very important, like how the channel is there. Channel roughness, that is called Manning roughness. I think some of you are with a background of water source you will come to know. That's very important in the event based model. How the channel is there, how that is the way the flow will come actually. So this that observations we need to take how the channel is there and accordingly we need to apply the coefficients. So some of the, you see how the this apply model will go actually, the cases actually. First one is observed rainfall, then we will go to observed rainfall and simulated runoff. That is a case 1 actually, like a, Then second case is like this. So observed rainfall, we are giving similar rainfall and then we are updating the runoff, means we are improving the runoff. That is the case 2. So then rainfall is observed, rainfall simulation we are doing and we are applying here the model, actually the M1 model. So then we are simulating the rainfall also, means like with this we are forecasting the rainfall, then we are applying that forecasted rainfall to this model. We are runoff, we are simulating, just we are simulating runoff. Then all the cases, okay. So runoff is forecasted, rainfall is forecasted, then we are doing after you can say this flow is coming, right, we are updating that one. So everything is like we are improving, means like it is like a fourth level, like a highest level we can take, like a rainfall we can simulate, forecast, runoff also we can simulate and then we can improve that one. So you can see this is the thing, it will explain all the things. So I think if you could able to get clear, means this is the way anybody can able to implement this type of forecast models. So you see the thing actually. Now you can see here what is the thing here, actually there is a 4 hour of rainfall is there, right. So with this 4 hour of rainfall is there in the R1, you can see, it's like a color, you can see the observed rainfall and then forecast and then observed runoff. So you can see here, say M1 model, you are applying the model. So it is like a, so it is like a M1 model, means rainfall forecast is there, right. You see the now 4 hours is there, now we are simulating the another 3 hours of this is what I am saying, the right now event is set, means event is happening. So now is already 4 hours of rainfall is occurred. So you simulated that another 3 hours of rainfall what is going to occur, okay. Then this will go to the forecast model. So you see now only here the 4 hours of rainfall is there, we can able to simulate the discharge, right, like a hydrograph, that is the last one is a hydrograph. So we can simulate this what is the runoff is going to occur at the outlet. So this one you see the 12 hours. So now in this one first what you have to know here is only 4 hours is the exact one, right, remaining 3 hours is what, forecasted rainfall, means what, with that forecasted rainfall with 3 hours is going to occur, means total of 7 hours, what is the, it is going to be the runoff we got, right, means event is still not completed, still is occurring. So you forecasted the rainfall and then 12 hours of the discharge you simulated, means it is going to, what is going to occur at the outlet you are already told, okay. So like this you see the, so now this is like just you simulated, means it may not be correct, right, we need to improve that one. So for that this will happen, means you see here what is the difference between this and this one. So here so here this blue color is there, right, this is like a observed, we can say the, we are simulating the 4 hours rainfall already occurred, right, means in the outlet of the that stream you are getting that by the time 4 hours is already spent, right. So you are going to get what is the observed runoff. So now we have the observed runoff and this is called simulated runoff. Next you can say the 12 hours and these are the next what is going to occur in this thing, means now to here you see these two things you will take and you will give to fuzzy model. So there it will try to improve this next you see up to the next like whatever the 7 hours you are simulated, right, this whatever the rainfall. So this next this one you will try to improve this one, since you have already some 4 hours runoff already available with you. So you combinedly do this error correction and you try to improve these results. You see when compared to this one it is better, right, it is coming close to the what is the observed one. So that way we can able to do the, you can see that is like a fuzzy model, forced one, that is a forecasted model, that is improved model. So where only we are correcting the discharge whatever we did here in this one, okay. So like this you see here how the things will happen. Then next one more hour, right, it is like this it will happen, 1 hour, next 1 hour. So with that 1 hour then it can do 3 more hours extra we are doing. You see it is a better simulation than the, you see this much you told that it is coming, but this much is only occurred, right. Next 1 hour also this you told like this much is only going to occur. It is better than this one or not? That is what is the like a improvement will occur when your model is happening. So you see you can say better you are simulating than this one, and then like a further improvement in the, you see this is like a further simulation. Like each hour, like 1 hour, it is like a lead time is 1 hour, like each 1 hour the model will go on update the things. So it will tell that okay, next you can say you are 1 hour lead time, this is going to occur, you can tell 1 hour, 2 hour, 3 hour lead time. Okay, same. So like this each and every hour it will continue. So every time the improvement will increase. So you are getting backup lot of observed data, right? Event is occurring, your simulation will become better and better. The forecast, you can say. So this is what is the, you see like this we can go on improve the things. So just like a complete simulation, just I will show you the how the what at the end how it will be. So you can see at the end is a complete picture like event. So now for example only you don't have any, you didn't do any simulation something, it is the event actually, some event occurred, and it is the, you can say the runoff by model, like whatever this one final runoff simulated by model, and this is like a blue color is the observed runoff. Okay. So it is like a rainfall and it is like a runoff without any model. So in between the model means we are all doing this predictions early, that is what is called forecast. Okay. So this is the overall, you can see the concept in the forecast. So this is the involves like a background, the you can say the models, data setting and all the things will be there. Okay. I said like a, we tried for this place, but they said like a, whenever the event set the start and we are getting receiving data with all the setup, there is like a flood occurred and it is got almost like a damaged. So you can't able to receive the data from the telemetry, and then we can't go on do the things. Then what we did is we did a like a backup thing, like already events are occurred will be there, like some places everything they recorded. So for those things we tried the simulations. So this is something like this. So this is the same like all these models, like a how like already event occurred means we everything is with us, right? Runoff, rainfall is available with us, runoff is available, then we try the forecast and you see how it is really doing for the data which is on the already occurred events. That is what we tried actually here. So this one all of those things, this is what I am saying important one, lead 1, lead 2, these are 3 things, leading times. Means what is the main observation you see, you tell me here, what is your main observation? So lead 3 hour lead means like a, for example now 3 hours later what is going to take, I am saying 2 hours and 1 hour. So 1 hour time lead is right, there is a more correlation, like a, it is better prediction. If you are go on moving away from the more time you are giving means it is reducing the accuracy. That is what is the main observation here. So most of the models will be like that. So since we are already some backup data will be there, we can go on improve. So this is where we can make in the forecast. Very very important in these forecast models. And one more thing is we are going using all those 3 models, rainfall forecasting and then runoff improvement. Then the accuracy will be more when compared to simply the only rainfall you are using and then forecasting we are doing. So you will use the all these things, rainfall forecast, model simulation, then forecast means improving the runoff also, then we will get the better thing. Okay. So this is like a, you see the when compared all these cases, you see this case is the better, means 4th type of model. That's what is the thing observation. So we tried the, you see the 4 like a different simulations we are using with the case 1, case 2, and these are all the like a different things. What is the main observation you have to get, like all those things, dotted lines like where you are going to simulate, and the blue line is the already happened. So within the lead time you can get all these things. That's what is the thing. What is the way I showed all things we can see in that way. So in all these things what is the main observed point actually what I want to tell you. So fuzzy logic, but now slowly it is converting into machine learning algorithms. Now fuzzy logic means that is all like a same type of mechanism we can provide in the machine learning. Somebody asking like a prediction we can do or not, we can do same type of things. So in the fuzzy logic is like a, we will also, there also will give it some training. So there will like it will make a some fuzzy inference. With the data set it will give a different alternatives. So then we can take all those alternatives, we will make it into one defined output and then we will make in the fuzzy model. Okay. But in the same thing we will do in machine learning also. We will train with the different type of algorithms. and we can see which one is the close to the some observed data set, that we can take as a simulation and we will do that one. But anyway, soon within next we can say couple of days we are going, we will come to know more about those things. Okay. So that like we can able to make that lead time runoff, we can how much you can able to do that improvement, that is all like we can do that one. And this is the overall you can see the we can improve the once after getting the runoff model, we can do that updating algorithm, that's really improve the forecast. Okay. So here same thing we told, like we are trying with like some event on these things. So then what we thought, like say it is like a very small basins we tried, like we are like going for a bigger basin. So just that thing I will tell you what is the way we did. This is the like exactly the spark, like as like a Sridhar and myself, and then we with one more professor from Texas A&M University. So this all like this is what we made as a real time forecasting model for the floods. So in that the SWAT model is one of the input. So we tried this one for the a bigger basin, same thing like we are explaining like Nagavali Vamshadhara basin, right? We tried for this one. So just I will show you quickly so that we can catch the time. So this is the like as we said, like we are previous Sridhar and we both like with other all the students, and then we made a very, you can say that almost like 4 years we worked on this one, this particular concept. So it's like a rainfall and temperature. Now we said like we are doing modeling, right? It will take time actually. So we thought like we can take some forecast already available from the GFS data, that we can improve. That is the thing. This thing means we are improving the already somebody's forecast. Instead of why we are doing, we do for small area, right? They will do for a big models, actually climate models, they will do forecast better. So this is what exactly the thing. So this is the way we can do the things, it will make better. So here we will do the forecast rainfall. That forecast rainfall we are giving for the SWAT model. So normally SWAT model is a continuous model, right? Already we built that one. So then we will apply for a one event. Then we can give the input that as a only for a particular event. So it normally work for longer duration, but one event data only will verify how it is occurring actually, how is happening. So here then whatever the in the SWAT model, right, we will only get SWAT model like a outlet, what is the discharge, like a hydrograph. On different parts of the, you can see that particular basin is there, we will get hydrographs, right. So that we will give input to this across. So that across will give you the, that what is the, what we can call as the flood. So you are getting at this forecast, how it will work. So forecast rainfall we will take from somebody, you will do bias correction, input to the SWAT model or any model, like we are tomorrow we are going to see like a HMS. Same thing we can do HMS also, or any WIC model, anything is okay. So then that inputs we give to the, only that any of those models they will give the hydrograph at different locations. Those things we give input to the across, that will give the spread of the like a flood. Each hour, each time step, what is the flood going to occur, it will tell. Okay. So most of the flood simulation now is happening with this concept actually. You can see either NRSC you are going to see, right, NRSC or other places, all some of these things they are following these concepts actually. So this is the finally we made a like a one, you can see WebGIS model where we can see this one. This is also we tried, it is up to some level. So we brought on, then further work is happening on these concepts actually to improve further, to make it as a real time. So here so this is the overall concept. These are all things already showed. This is the like a, to get all the basic data sets of those things. So all the team they are like this is like a first like a one cyclonic event is there, right. That what we did is like a cyclonic event also, what we thought like a better maybe go for a WRF model, weather resource forecast model. So one cyclonic event is going to set, right, we give the boundary conditions, we can simulate also. You see in this case the rainfall it is we can able to make actually, so simulate actually. So this is like a one, we are, you see like this is like a spreading when it come into land, right. So there we will come to know what is the, it is set somewhere in the ocean, right. It is time will take, right, it is coming to landfall. So by that time we will come to know how much rainfall is going to occur on the land. That is the input first of all, that is what is the thing this WRF model will do. So in the WRF model any event it is set means with the boundary conditions we can able to simulate the, what is the, you see this is set by the time it is coming here we can forecast. That we can give as the input to the next you can say the SWAT model. So now after that thing whatever is the, you can say, the model. So we will give to the SWAT model with all those inputs, field observations, everything. Then it can simulate. It's like a, we are doing for normally for a long term, but we will apply in that wherever there is event occurred. Once model is set right, calibrate, validate means later it will work. Any event you can give input, it automatically will simulate. That's what is the concept here followed. So here once after doing that one, that input is taken and then applied on this. You see from here to here, this is the main, you can say, the reverse stretch. It's a two-dimensional flow actually. Two-dimensional model, it is set that this across model which you are going to see. One-dimensional maximum we are planning to explain you. You can see how this is set and then how you can apply. So different points, like you see this is a one junction. There are the different locations, right? All those places you can give the hydrograph as input. So that hydrograph we can once after simulation with this across, right, you will come to know how the flood spread is there, like a, you see this is like every time step, how the flood is going to spread on that, we can see the area. So like every time step we can see what is the way the flood going to distribute actually. So this thing like a, our main goal actually our plan is like this, making as a WebGIS model. Like WebGIS means like anybody can see, like for example we keep in our website, website, it is going to occur, event is going to occur, everything we can do an automation. We could able to see that forecast how that runoff is going to, flood is going to come in a area. But we didn't reach the stage, but it is a different, means at the level of, we made as a backup model, we prepared this thing. So it is up to some level of accuracy, it is working currently, so but we need to work on this one. Yeah, that's what is the main thing actually here about this one. So now this is one of the best times you can see for the forecast systems. So lot of things are happening in this area actually. So like where PSRV is fuzzy or other things, right? This AI and these things will make it better. Since like a lot of variations are possible, we can make the lot of, we can say, the training well in advance for so many events, right? So it will take those things, okay? And lot of things is happening in this area, like a speed in the, you can say this, what we can call a computational speed. In future really somebody interested in forecasting, right? That is one of the area where you can try. Lot of things are changing like speed. So now what is the current like a level of competition is happening in the simulations or simulation aspects. So now current simulation is maybe sometimes they may there, later they are going for the more you can say changed version of the simulations is happening at quantum computing. But it may not happen immediately, but this area like where especially weather forecasting and hydrological, especially the flood, all those things forecasting, they are going for a quantum computing where this all will occur in a more speeder way, okay, on parallel computing. So if you are available a higher speed like a computing at a parallel level, you have to make early, right, 1 or 2 hours early you have to simulate, right. That is possible with these things actually, okay. So then these are all like a connected things. You need to have this type of systems, you need to have this type of systems, and then these things, then you can make your forecast better. Most of the, like we are visiting place, right, NRSC and INCOIS we are visiting, right, those in the, you can say there. So you can see some of these things, systems they are developing, you can appreciate and you can see those things. On a Sunday we are planning to where networks in the, this I connected, these are all connected things, not like alone independent. Like we need to measure something at accurate at gauge stations. That has to be telemetry, we need to send to the places to the, I can say all the, I can say database. So this they are doing at the gauge stations also. So we will visit some of those gauge stations, how they are doing really. So those things we will check actually. Okay. So that's all, like this is about thing. Yeah. So the further like here now lot of sensing techniques, right? No need to depend on somebody's actually. We can make our own open hardware. That is like a current one of the, we are using one more, you can say, project we are working on those things. How to make the sensing instrument to measure some of the process. Okay, that's a different thing. So anyway, this is all things. Now it is like a open. 2 minutes we will conclude the things. We are done with the class. So why it is important actually, this forecasting actually so much, anybody, any modelers especially for this domain, they are very much interested in this thing. Why we are so much interested in forecast? Early warning system to develop and finding the impact, reducing the risk, all the things is very important actually. So event based forecast, which are the models? So current actually I said like a heck HMS you are discussing, and heck cross for the flood, wick models, those things are like a very well you can say especially events which are very like a small events are occurring, you can go with that models. So like a current technology is like a simulation, sensing net, those things, so they are all like important in those things. Yeah. So like whatever I said, like we are discussed actually, there's like a one like our group actually with scholars like myself, Sridhar, and then these are all like a other professor from Texas A&M. They're all like a, everything is available in public domain now. All are available. So some of you are really interested, you can take up some of these things and you can read. Whatever I have presented, everything is available in the now public domain actually. So that's all for this thing. So any other things, questions, or otherwise we will stop at this point. Yeah. Yeah, that is the exactly where the one is like a one previous concept is a fuzzy inference system, right? So we will try to see the previous one, right? Previous things. There is observed and simulated already. We are some old events are there. So already we know like whatever we are simulating and what is the error we are going to get. So those things we will take the error. That error reduction algorithm is there. Means like we try to make that reducing the means we try to bring the whatever the simulation toward the observed one. So there you will get some coefficient, right? Like that first one is like how the simulation fuzzy inference will take place. Both are input and output is known. Then you tune for the coefficients, right? That coefficient you will apply for the next, you can say in the next time we are applying, you will apply the coefficient for the simulation. There we will get the runoff. Transfer functional, that is called actually fuzzy inference system. There is a all those algorithms available in the we kept in the papers. Actually there is some algorithms are there where we can get that that fuzzy inference. There we can call as the fuzzy inference functions or fuzzy inference system. So every rule like this is the error, this is the way it will come the thing. Like we will make some rules. Accordingly each rule like we will try to make some weightage. Like a 3-4 weightages will come, right? Like this is the particular simulation, this is the error, this is the coefficient. So like that we will make some rules, right? So later when simulation comes, what it will make? Same rule it will apply. So everything it will come some coefficient, right? It is weightages. That is called actually the fuzzy. It is not a different. So then once again what you will do is you will convert into defuzzification. We will convert that into exact value based on the weightages. Then we will get a one value that we will present to the forecast. Okay. So more details like really interest means you can see those things actually all those things are available in the paper. So you can see really lot of all the background equations, those things, everything is presented. You can really somebody interested means you can see, and any discussion on those things also, since all those things we both are involved, most of the things actually you can get to any aspects of forecast, those things we can explain to you more leisurely. Is that okay? We will stop here, then we will proceed for the lunch and we can join to the afternoon session. So you may take extra like a 5 minutes, like we may start at around 2:30 we will start, then 2:30 we will start, so that we will take some breaks since okay, right, 2:30 these things. Yeah, 2:30 we will join for the next session. So by that time everything will arrange. But you want to make any announcement? Yeah. So this gap you will get almost the things. We are done with the class. So why it is important actually this forecasting actually so much, anybody, any modelers especially for this domain, they are very much interested in this thing. Why we are so much interested in forecast? Early warning system to develop and finding the impact, reducing the risk, all the things is very important actually. So event based forecast, which are the models? So current actually I said like a heck HMS you are discussing, and heck cross for the flood, wick models, those things are like a very well you can say especially events which are very like a small events are occurring, you can go with that models. So like a current technology is like a simulation, sensing net, those things, so they are all like important in those things. Yeah. So like whatever I said, like we are discussed actually, there's like a one like our group actually with scholars like myself, Sridhar, and then these are all like a other professor from Texas A&M. They're all like everything is available in public domain now. All are available. So some of you are really interested, you can take up some of these things and you can read. Whatever I have presented, everything is available in the now public domain actually. So that's all for this thing. So any other things, questions, or otherwise we will stop at this point. Yeah. Yeah, that is the exactly where the one is like a one previous concept is a fuzzy inference system, right? So we will try to see the previous one, right? Previous things. There is observed and simulated already. We are some old events are there. So already we know like whatever we are simulating and what is the error we are going to get. So those things we will take the error. That error reduction algorithm is there. Means like we try to make that reducing the means we try to bring the whatever the simulation toward the observed one. So there you will get some coefficient, right? Like that first one is like how the simulation fuzzy inference will take place. Both are input and output is known. Then you tune for the coefficients, right? That coefficient you will apply for the next, you can say in the next time you are applying, you will apply the coefficient for the simulation. There we will get the runoff. Transfer functional, that is called actually fuzzy inference system. There is a all those algorithms available in the we kept in the papers. Actually there is some algorithms are there where we can get that that fuzzy inference. There we can call as the fuzzy inference functions or fuzzy inference system. So every rule like this is the error, this is the way it will come the thing. Like it will make some rules. Accordingly each rule like we will try to make some weightage. Like 3-4 weightages will come, right? Like this is the particular simulation, this is the error, this is the coefficient. So like that we will make some rules, right? So later when simulation comes, what it will make? Same rule it will apply. So everything it will come some coefficient, right? It is weightages. That is called actually the fuzzy. It is not a definite. So then once again what you will do is you will convert into defuzzification. We will convert that into exact value based on the weightages. Then we will get a one value that we will present to the forecast. Okay. So more details like really interest means you can see those things actually all those things are available in the paper. So you can see really lot of all the background equations, those things, everything is presented. You can really somebody interested means you can see, and any discussion want on those things also, since all those things we both are involved, most of the things actually you can get any aspects of forecast, those things we can explain to you more leisurely. Is that okay? We will stop here, then we will proceed for the lunch and we can join to the afternoon session. So you may take extra like a 5 minutes, like we may start at around 2:30 we will start, then 2:30 we will start, so that we will take some breaks since okay, right, 2:30 these things. Yeah, 2:30 we will join for the next session. So by that time everything will arrange. But you want to make any announcement? Yeah. So this gap you will get almost